Okay, so you guys, if you want to try the YouTube streaming, what you can do is copy and paste this link, and I think I can talk to you through the YouTube stream for it. So if you want to just try to copy and paste that link in, and then we can go over, or if you just want to watch the pre-recorded videos, that is fine as well. Okay. Okay, Google, turn on the studio lights. Okay, perfect. So again, if you want to join the YouTube session, there's a little bit of a lag, but I think we will be good. Now, what I'm going to do is, Jordan, can you hear me? Can you hear me on the YouTube? Oh, no, wait. Can you hear me? Okay, we'll try this. Okay, so with this, okay, so you guys can see it and you can hear it on the YouTube. Or maybe you can see the paper now. I do not know. Sometimes Blackboard has like such a weird connection. Okay, let's try it again here. All right, so what we're doing is we're trying to condense and then set the arguments equal. So what we'll do is we first condense and we're trying to get either 1 log is equal to a number, or we are trying to get a single logarithm equal to a log. Okay, so when you look at this question below here, again, you're going to identify where your variables are. So you have a variable in this argument, variable in this argument. You'll notice that you have 3 logarithms. So you want to look on the left-hand side and say, okay, is that log as condensed as it possibly can be? And in this case, there's nothing to simplify further for the log. So you'll have log of x plus 4. And then on the right-hand side, again, same idea. You're asking yourself, can I condense that logarithm as much as possible? And here you have addition of 2 logarithms. So because you have 2 logs added, you know that that can go to 1 log with multiplication. So what you'll do is you'll say, okay, this log of x plus log of 4 can become of log of x times 4. Okay, so now you have a single logarithm that's as condensed as possible. And then on the other side, you have a single logarithm condensed as possible. Okay, so you have condensed, you have quote unquote undone your PIMDES as much as you possibly can with the addition, subtraction, multiplication, and division. You're kind of at that exponent log level where you're trying to figure out, how do I get rid of the log? Now, we're not going to do the raise equal to because we don't have a single logarithm. Here, we look at this and we say, okay, we have a log and a log, so those arguments can be set equal to each other. So we condense, and then because of this structure, we're going to set the arguments equals, and then the x times 4 just becomes 4x. Okay, so we set the arguments equal. That gets rid of our log problem, and then we just kind of carry on with our normal way of solving. Okay, so to solve for x here, we'll probably subtract x from both sides, and that will give us x is equal to 4/3. Okay. Now, remember that with logarithms, this is not a final answer until you check that domain restriction. So you have to check and make sure that you only have a is equal to log of x plus log of 4. Okay, and we'll plug in that proposed solution of 4/3. So that will give us log of 4/3 plus 4 is equal to log of 4/3 plus log of 4. Okay? And all we're trying to check for is that these parentheses, these positive parentheses exist. So we have a positive parentheses here, so that checks out. Positive parentheses here, that checks out. Positive parentheses here. And so that means that our final answer is going to be the 4/3, that x is equal to 4/3 because that domain restrict. So we'll go over here and look at page 37. And again, for page 37, same idea. You're going to identify where your variable is and then what type of equation you actually have. Okay, so the first thing you're going to do is you're going to say, okay, where is my variable? So here is my variable, here's my variable. So because that variable is inside the log, we have a log equation. And the first step for log equations is going to be to condense as much as we possibly can. Okay, so we're going to look at these two logs and we notice that these two logs are being added together. Okay, and we know that if you have one multiplication inside, that goes to two logs added and vice versa. So this will become log of, and then we're going to have a parenthesis for the argument, and then a parenthesis for the x plus 7 argument, x plus 4. And then close that parenthesis. So all of that is your argument. Okay. All right, so we have condensed it, and what we're trying to do is we're trying to undo PIMDES, and at this point, like the only thing we have on the left-hand side is the log. And so now we have to, after we condense, now we have to figure out a way to undo the logarithm, okay? And the only way that we really know how to undo the logarithm is to do this raise equal to, okay? Now, we're not doing the whole set the arguments equal here because we don't have log equal log. So over here, we had a logarithm equal to a logarithm, so we could set those arguments equal. But here, we just have a single logarithm equal to a number. And so to undo that logarithm, we're going to do the raise equal to. Okay, now for the raise equal to, let's kind of think about that. What is our base of log? Our base of log is 10, and we're going to take that 10 and raise it to the first power. So this is going to be 10 to the first, and then that is going to equal the argument. So it's going to equal all of that argument, which is x plus 7, x plus 4. Okay? So that effectively gets rid of our logarithm. But now that we get rid of our logarithm, we have to solve that equation. Okay? Are there any questions about that? Okay, so usually when you're solving the equation, the way that you're going to go about that is if it's not a quick, easy isolate x, most of the time what you're going to see is you're going to have to move everything over and factor it. Most of the time, if it's not just solve for x easily by a linear equation, there is going to be some factoring involved. Okay, so what we'll do is we'll move over, but before we move everything over, we do have to FOIL out these parentheses. So that's going to give us x squared plus, we have a 4x plus 7x, so that gives us an 11x plus 28 is equal to 10. And then we'll subtract 10 from both sides and get 0 is equal to x squared plus 11x plus 18. And then now we're in the position where we can factor. We think about factors of 18 that add up to 11, and we get x plus 9 and x plus 2. Okay? And then set those factors equal. And that gives us x is equal to negative 9, and x is equal to negative 2. Okay? Now remember, with logarithms, those are just your proposed solutions. You cannot say definitively that that is your answer until you check your argument. So the last step is to check and make sure that you have that positive parenthesis, that positive argument. Okay. Now, when we're checking, we always have to check back into the original equation. So our original equation is up here. We have log of x plus 7 plus log of x plus 4 is equal to 1. Okay, and we'll start by checking the negative 9. Okay, now keep in mind, you're not checking to see if the x is negative. What you're checking for is a positive argument. So that's your check step, is that that parentheses quantity is positive. So you'll have log of negative 9 plus 7 plus log of negative 9 plus 4 is equal to 1. And again, all you're after is this argument positive? So here you have negative 9 plus 7, that gives you negative 2, and that is not a positive argument, excuse me. That is not a positive argument. That negative 9 is not going to work for us. So negative 9 is not a solution. Now, Stephanie, what is your question? The 10. The 10 right here? Okay, that 10, good question. So that 10 comes from the fact that I'm going to write it here if that's okay. But if you just see log, okay, and let's say it's log x, the understood base is 10. Okay, so you have to kind of superimpose this. So when you just see the log, you have to say, okay, that means that the base is going to be 10. Okay. Does that make sense, Stephanie? Okay, so that's where the 10 came from. And again, I do want to just say one other thing about this. Like if you see natural log of x, because this will be something on your test for natural log, if you see just natural log, the understood base, or you can just say the base, is equal to e. Okay, so they're not going to actually put the e there, but there is an understanding that it's e. Okay. All right. Okay, that's a good question to ask. Thank you for bringing that up. Okay. Any other questions up to here? Okay, so negative 9 does not work for us. So then we have to go and we have to look at x is equal to negative 2 as our other proposed solution. And again, we're plugging that into the original equation. So we have log of negative 2 plus 7 plus log of negative 2 plus 4 is equal to 1. Okay, and all we care about is, do we have a positive argument? So we look at this parenthesis, negative 2 plus 7 gives us a positive 5, so that does check out. And then the negative 2 plus 4, that is a positive 2, so that checks out. Okay, so that tells us that negative 2 does work as a solution. So you're going to have to include negative 2 as your only answer. The negative 9 is going to be eliminated. So your answer is x equals negative 2. Okay. Are there any questions about that? Okay, so I want to just take a little moment here and kind of talk about a summary of the work that we have done so far. And if you have the note packet in front of you on page 38, maybe just kind of like flip it around this way. And we're going to talk just very briefly here about kind of like the two different types of equations that you have. So one situation is you have a variable in the exponent. Okay, so if the variable is in the exponent, or you can have the variable inside the logarithm. So that would be a log equation, exponential equation. Okay. Now, both of those types of equations, anytime you have an equation, you're going to think about, I need to undo PIMDES. Okay. So that undoing PIMDES basically amounts to, if you have a variable in the exponent, you're going to isolate the base plus the exponent. That is your undoing PIMDES. Okay. If you have a variable in the logarithm, then you're going to condense it using properties. Okay? So you'll have your whole 1 multiplication goes to 2 logs added, your 1 division goes to 2 logs subtracted, and your powers can come down in front as coefficients. Okay? But all of this is trying to condense, get it as a single logarithm. Okay? Now, let's stick with this variable in the logarithm part. So after you condense it, then there's like 2 situations that can happen. Okay? One situation is that you can have a single logarithm equal to a number. Okay? And if that happens, if you have a single log equal to a number, then the way that you're going to undo, so this really is like step 2, where you're going to try to undo the log. And if it's a single log equal to a number, the way that you undo that logarithm is with the raise equal to. Okay? So if it's 1 log equal to a number, then you're going to do your raise equal to. Now, if, on the other hand, you have a log equal to a log, then you don't have the little wave, the raise equal to. In that case, you're going to set the arguments equal to each other. So you're going to kind of think about the logs crossing out and just setting the arguments equal to each other. Okay, so step 2 is somehow you have to undo the log. The way we do that is either if it's 1 log equal to a number, you'll do the raise equal to, and if it's a log equal to a log, then you're going to set the arguments equal. Okay, now that gets rid of your log. So you solve, you go on your merry way and solve it. And then the 4th step is that you have to check for a positive parenthesis quantity, because remember that parenthesis quantity is your argument. Okay? So the only time in solving equations in test 4 that you actually have to check it is the only check is for log equations. Okay, so all the other equations, like exponential equations, you don't really have to check it if you don't want to, but you have to check for a log equation. Okay, so a log equation, first step, condense it, undo PIMD as much as you possibly can. Then if you have 1 log equal to a number, you'll do the raise equal. If you have a log equal to a log, then you're going to set the arguments equal. Okay. Another type of equation that happens is the variable and the exponent. And that is going to be to isolate the base plus the exponent. And then there, you have to somehow undo the exponent. And that, just like undoing the log, you have 2 different ways. One way is that you can get a common base and set the exponents equal. The problem with is that does not always work. So I wouldn't bank on like getting a common base. Like it's fine if it happens, but most of the time what's going to happen to undo that exponent is you are going to take the natural log of both sides, and then you're going to use your log properties. So the log properties, so you take the LM, and then you use, and the log properties again are going to be that you are going to either set have the same bases cancel, or bring the power down in front as a coefficient. So it's either going to be power going down in front as a coefficient, or the same bases cancel. Okay. And you'll notice for exponential equations, you do not have to, whatever answer you get, that is your answer for the exponential equation. Okay. Now, I do want to just make another about this. When you're talking about getting the same bases canceling, you're going to have like log of e to the x. Again, the natural log has base e to the x, they cancel, and you're just left with x. Okay, so that's when we're going to see that the same bases are going to cancel. Okay, are there any questions about that? This is the whole section 4.4. And then if you have what you need, look over on page 39. And on page 39, they have kind of like this question that I want you to look at and think about how you would approach that. Okay, unfortunately, I have to get a mint here. Okay. Any questions? All right, so let's look over here at this next page. And on this next page, what they're doing is they are trying to take a formula that we have seen before for the n compoundings per year, and we are trying to basically figure out the time take for our investment to become a certain accumulated amount. So you will see this again on test 4. You'll see a question where you have to use this formula, and this formula is for not continuous compounding. It's for n compoundings per. So what we have here is we have 10,500 that's invested for 2 compounding periods. So that means that you're semi-annually to be computing interest. Interest rate is 6.25%, and then our accumulated amount is 22,000. Okay, so we kind of start here with just the variable expressions and what these mean. So you would have A is equal to P times 1 plus R over N to the NT. Okay. Now, the amount invested is going to be your principal. So P is going to be this 10,500. And then the number of compounding periods is your N. So N is equal to 2. And then your interest rate, remember that with interest rate, we always have to move the decimal 2 places to the left. So what will happen is you'll say that your interest rate, you'll move this 2 decimal places to the left, and you'll come up with your interest rate as 0.0625. Okay? And then your accumulated amount is your A value. Okay, so the first step for this question is just going to be to plug in those variable quantities that we have. So we have that A is 22,000. We have that our principal is 10,500. We have that our interest rate is 0.0625. And then our N value is N is equal to 2. And that's raised to N times T, so 2 times, and then the problem here is that we do not know that time, that total time, so we have to leave it as a T. Okay, so that's our setup for the equation, and now we have to identify like where our variable is. So our variable is in the exponent. So we write out our equation and then we say, okay, our variable is in the exponent. And so what we want to do is we want to undo our PIMDES as much as we possibly can by isolating the base plus the exponent. Okay, so here's my exponent of 2t. My base is this 1 plus 0.0625 over 2. Okay, so that quantity needs to be as isolated as much as possible. Okay, and if you look at it, like if you're trying to undo your PIMDES, you would say to yourself, okay, I don't have addition and subtraction, but I do have multiplication. I have this multiplication of this 10,500. So my first step in terms of isolating the base plus the exponent is going to be to divide both sides by the 10,500. Okay, so then those guys cross out. The thing is, when you plug in 22,000 over 10,500, you are going to get a crazy decimal, and we don't really want to introduce crazy decimal into the problem. Okay, so this is really important. You are not going to use that decimal approximation. You're going to say to yourself, okay, these zeros cross out, and the simplification of this fraction can be 2,200 over 1050. Okay, so you're going to not sit there and like actually use a decimal approximation. You're just going to do it's 2,200 over the 105. And then that's going to equal on this right-hand side. Okay, we have 1 plus And if you look inside the parentheses here, you have this 0.0625 divided by 2. So to kind of simplify our work, simplify that parentheses quantity, we will make that division happen, and we get 0.03125 raised to the 2t power. Okay. So this is after we divide by the 10,500, then we get to this point. All right. Are there any questions about that? Okay, so at that point, you've isolated your base plus your exponent, and then your second step is to undo that exponent. Okay, now the question is, well, how do you undo that exponent? You're not going to get a common base between these two numbers. So that tells us that we're going to take the natural log of both sides. Okay, so we're going to apply the natural log here, and we're going to apply the natural log here. Okay, now the whole reason why we're taking the natural log is because we want to undo that exponent. And the way that we can do that is use the fact that the power can become a coefficient. So this is going to become the natural log of 2200 over 105 equals, and then this power of 2t is going to come down in front. So it will be 2t natural log, and then you'll add the 1 plus 0.03125 to get to this. Okay. Are there any questions about that? Okay, so at that point, you have your two sides of your equation, and you're looking at t right here. And so the question is, how do you isolate t? So to isolate t, you're going to divide both sides by 2, but you're also going to have to divide both sides by the natural log of 1.03125. So you'll divide by 2 and this natural log of 1.03125. Okay. All right. Now that gives you a very involved answer. And what I would do on your calculator is just go ahead. Again, this is what you're trying to type in on your calculator. Okay. And so what you would do is you would have natural log of 2200 divided by 105, and then divided by, and here you'll notice that you have two factors in the denominator. So you have to put a big parenthesis and then do the 2 times the natural log of 1.03125, and then close your parenthesis. Okay. And again, this parenthesis here to show that all of that quantity is in the denominator. Okay. So it would look like on your calculator, you would have natural log of the 2200 over 105, and then divided by parentheses 2 natural log 1.03125, close your parentheses, close it again, and that will give you 12.01, which will be rounded to 1 decimal place of 12.0. Okay. Right. Are there any questions about that? Okay, I do want to tell you something that's very important. You guys, this type of question, you're not going to see something that involved on your test 4. So this really is for homework only. The other thing is on page 40, there's another question that really is just kind of like putting it all together for a homework only type of thing. But what you'll see for test 4 is just going to cover section 4.1 through 4.4. So it only covers those 4 sections, but again, they're pretty hefty sections. On the final is cumulative, so it covers everything for the entire semester, and it will cover section 4.5. So it would be helpful if you do this before test 4, but you'll see that on Blackboard here, maybe I can get this to be shown correctly, but you'll see on today you have 4.4. That is the priority for test 4. But then I also want you to look at section 4.5. Section 4.5 is not on test 4 officially, but it applies and puts together all of those test 4 concepts, and it will be on the final. So if at all possible, if you can, okay? Are there any questions about that? The test 4 review here, and there is playlist that you can watch if you would like to, and it really goes through from start to finish the different concepts that you're going to need to know. And it's not that long, it's only 30, are the top 30 concepts that you need to know for the test 4. Okay, and I don't really know why I have this in there, but I'll need to take that off. Okay, questions about that? Okay. And test 4 will be very similar in structure to test 3 in the sense that it's on Blackboard, and then you have to upload your work and show all work in order to receive credit. Okay. All right, you guys, well, have a great day. And if anything comes up, when is test 4? Okay, so test 4 is on Wednesday. So this Wednesday. So if you look here under your schedule for virtual classes, when our test 4 is. Okay, and then we'll have the final after the following Wednesday. But I do want to have a day in between so that I can show what your results were on test 4. Okay, are there any other questions? Okay, all right, you guys, so have a good day, and we will talk to each other on Wednesday. But again, Wednesday is our test 4, and that's when we're going to focus on taking test 4. Then Monday will be review, and then the final the following Wednesday. Okay, all righty. So I'm going to stop the recording now, and I will talk to you guys on Wednesday, if not before. 10:33. Okay. Okie dokie. So what we're going to do today is we're going to start by looking at one of the My Math Lab questions where you have kind of, so what I want to do is I'm going to switch from this screen over to the DocCam. So the question, you'll see this for sure on test 4, where you're wanting to graph the minus 4y is equal to 16. Okay, so the first step here is going to be that you are going to solve each of those equations for y. So the first step is to solve for y. So remember, and again, this was discussed in the videos for the lecture today, but you have your tests or your section equation 1 and equation 2. Okay, so my first step is going to be that I solve equation 1 for y. Okay, and again, this is number 5, the homework from mod 3. Okay, so we're going to solve for y. We have our first equation, x plus y is equal to 1. We subtract x from both sides, and we get y is equal to negative x plus 1. Okay, and again, those are unlike terms, so we cannot combine them in any way. We just have to say it's negative x plus 1. Now, what you're going to do when you get this negative x plus 1 is you're going to then go about identifying your y-intercept. Now, your y-intercept, okay, I'm a little worried because I'm seeing some people pop in and out. So, okay, can everybody see my screen okay? Hopefully. Okay. All right. So you're going to solve for y, and when you solve for y, you get y equals negative x plus 1. So now what we have to do is we have to graph that equation. So let me go over here. So your y-intercept is going to be the by itself number. So your by itself number is going to be your y-intercept. And that again is just going to be 1. So you're going to plot that on the y-axis. Okay. And then your slope is the negative x. So that's going to be our slope of negative 1 over 1. So that tells us that we go down 1 unit and then to the right 1 unit. Okay. So on the My Math Lab program, icon, and then you're going to click 1 on the y-axis. And then to get your other point, so your first step is plot your y-intercept. And then to get the other point, you're going to use your slope. So in this case, our slope is negative 1 over 1. So we're going to go down 1 and then to the right 1. And then click, and that becomes our next point. Okay, so we have our first line drawn. And now we have to draw our second line by solving. Okay, so we're going to switch over here and we're going to solve the second equation, the x minus 4y is equal to 16 for y. So to do that, we will subtract x from both sides and get negative 4y equals, and then the 16 and the negative x, those are unlike terms, so we keep them separate at negative x plus 16. And then divide all 3 terms by negative 4. So that gives us y is equal to x over 4, because you have your double negative there. And then the 16 over negative 4 gives us a minus 4. Okay. All right. So then what we're going to do is we are going to look at our y-intercept, our by itself number. And so our by itself number is negative 4. So that's going to go on the y-axis. And then our slope is our second point, or going to give us our second point. And that second point is going to come from a slope of 1/4. Okay, and that 1 again is going to be up 1 unit, and then to the right 4 units. Okay, so what we'll do on my math lab is we're going to first plot the -4 on the y-axis, and then we're going to go up 1 and to the right 4. Okay, so I'm going to switch over here to my math lab. So we're going to click the line icon again, and then we're going to click -4 on the y-axis. And then is that once you solve for y for both of those units, then your answer for the linear system, your answer is going to be the point of intersection. So wherever they intersect, so that intersection point is going to be the answer for the linear system. So in this case, our intersection happens right here at 4, -3. So what we'll do is we'll save the graph and then check our answer. Hopefully that checks out. And then when they ask us for what type of solution we have, we say that there is one solution, and the solution comes from this point of intersection. So that point of intersection is 4, -3, and it is a point. So we're going to type parentheses 4, -3. I'm going to close your parentheses, and then that is our solution to the linear system. Okay. All right. Are there any questions about that? Okay. All right, so I'm going to switch over here to the .cam, and what I want to talk about today is kind of a review for the material that we're discussing for test 4 on Wednesday. And so what we are going to do is we're going to go through these review cards that I gave in the email that I sent out to you guys at before the weekend. So you can also find these if you go to today's lesson. Oops. So if you go over here to them and then scroll down to April 13th, you will see that under April 13th, there's this test 4 review cards, and then test 4 review filled out. And I want to kind of go through these review cards in your pre-quiz this week. Okay. All right. So the first thing that we're going to do is we're going to look at kind of a review of the very beginning, section 6.1, where we have, okay, I'm worried, can you guys see the review, like can you see 4x minus 11? Because I am not seeing that. No, see that's what I was, because you see like just solve that. Let me, one second here. Okay, so you can see the Firefox thing, but you cannot see. Okay, just give me a quick second. I'm going to try to restart my video. It was working just like at 9 or 10:45. Everything was working fine. Okay, now can you see the 4x minus 11? I think you can. No, wait, that's from the Firefox. Let me go .cam. Okay, let me try one more thing. Okay. Just give me 1 minute and I'll be right back. I have to check something. I don't know why it's not showing this. Hey, Nick, do you have a minute? Okay, so I think now can we see it, Alexis and everybody? Can we see the 4x minus 11? I think we're good. Okay. All right. I'm sorry about that. I don't know what exactly was going on there, but so these are the review cards that we're going to be going over. And this first one is this 4x minus 11 over x squared minus 12x plus 35. And then you're adding that to this other fraction. So here is what is important about this. On your test 4, when you're working through this, you're going to first emphasize that addition sign, okay? And when you see that addition sign, when you're adding two fractions, you need to get an LCD. Now, in this particular problem, you have an LCD. You have the x squared minus 12x plus 35. So because you have an LCD, you can go straight to step 2, where you add the numerators together and write that over your common denominator. Okay, so what will happen here is you'll have one big fraction where you'll have x squared minus 12x plus 35. And then in the numerator, you're going to add the 4x minus 11 plus 4 minus 3x. Okay, and then we're going to combine our like terms. So the like terms to combine here are the 4x minus 3x will give you just x. The 11 plus 4 gives you negative 7. And then that's over x squared minus 12x plus 35. Okay. Now, the key thing that you want to remember is that your last step in any fraction question, okay, so if you have any sort of fraction question, your last step is always to factor and cross out factors. And that is, again, the process of simplification. So simplifying a fraction means that you factor and cross out the factors. Okay, so what I would do when I get to added the numerators, wrote it over that common denominator, is I would then factor this denominator. So I would think about factors of 35 that add up to negative 12. Okay, and that would give us negative 7 and negative 5. Okay, so we'll write this as x minus 7 over x minus 7, x minus 5. Okay, and then at that point, the x minus 7's cross out. And if they cross out, there's nothing left in the numerator. So remember that that crosses to 1 over x minus 5. So your final answer will be 1 over x minus 5. Okay? So the first type of problem that you're going to see is the idea of you're adding, you're going to get an LCD, and then add the numerator and write that over the common denominator. And then your last step with any of these fraction questions is always to factor and cross out the factors. Okay? All right, so if you look at this next one, just take a minute, write down the question, and then think about what your first step would be in solving that question. Okay, so the very first step is always going to be to identify that operation in the middle. So here we have a subtraction sign, and so when we have a subtraction sign, we are always going to distribute that to the numerator that follows. So this is going to become a plus sign and then distribute. So it'll become negative x minus 3. Okay, so that's our first step, is to distribute. Now, just to kind of hopefully make it a little bit more clear, I'm going to write this problem down below here. So you have x minus 5 over x plus 6 plus negative x minus 3 over x minus 6. Okay, so let's just kind of look at it from that perspective. Now, when you're looking at the plus sign now, you're going to say to yourself, I have to get an LCD. And that LCD is going to be the different factors raised to the greatest power that you have. Okay, so you're looking at the denominator factors and what are those different factors. Now, in the case of this denominator, you have x plus 6 and x minus 6. So what's going to happen is those are completely different factors, x plus 6, x minus 6. And those two factors multiplied together will be your LCD. Okay? So what you'll do is you'll say, okay, this first fraction, it has the x plus 6, so it needs the x minus 6. So the first fraction, you'll multiply by x minus 6 over x minus 6. Now, the second fraction, again, you'll look at the second fraction and say, okay, it does not have x plus 6. So that second fraction needs an x plus 6 over x plus 6. It has the x minus 6, and so now it has that complete LCD. Okay? So I want to be clear on your test, if you just write the multiplication in by the x minus 6, multiplication in by the x plus 6, you get partial credit for that because that is the first step, is to identify that LCD. Okay? All right, now the whole reason why we're getting that LCD is once we have our LCD, then we're going to add the numerators and write that over our common denominator. Okay, so we're looking at this expression here. We're going to make it one very big fraction where we have x minus 6 and x plus 6. Okay, now in the numerator, to add these numerators together, so all this numerator, we are going to have to FOIL out that numerator expression because you cannot add parentheses with another parenthesis. So this numerator is going to involve FOILing, and for this first one, we get x squared, and then minus 5x minus 6x gives you a negative 11x. So we have x squared minus 11x, and then the negative 6 times negative 5 gives us a positive 30. And then we have plus, and then we'll FOIL out the second fraction's numerator. So we'll have negative x times x gives us a negative x squared. And then the outer will become a negative 6x, and then the inner will become a negative 3x. So that will give us negative 9x. And then the last two multiplied together, you have a negative 3 times a 6. So that gives us a negative 18. Okay, so again, to add the numerators, we essentially have to FOIL out the numerator. And then now that we have these individual terms, we can actually add those like terms. So we'll have that the x squared and the negative x squared cross out. Then you'll have negative 11x minus 9x to get a negative 20x. And then you'll have the 30 minus 18 to get a positive 12 over x minus 6, x plus 6. Okay. So our last step after we add the numerators, write it over that common denominator, is that we are going to factor and cross out factors. So when you look at factoring negative 20x plus 12, there's only a GCF of negative 2 that you can take out. So you take out that negative 2, and actually there's a GCF of 4, negative 4 that you can take out, and that gives you 5x minus 3 over x minus 6, x plus 6. Okay? Now, the problem here is that you notice that there's nothing to cross out. So you take out the GCF, but that doesn't actually help towards moving you towards factoring and crossing. So this is your final answer. However, you could also leave it at the negative 20x plus 12, and that would be fine as well. Okay? All right, are there any questions about that? Okay. So the next question is written here. So again, kind of get caught up in your notes and then look at this next question, copy it down, x squared minus 16 over 8 times, and then this fraction. Okay, so the first thing that you want to do, just like with the last two problems, is you want to identify what is the operation in between those fractions. So here you have multiplication. And when you identify that multiplication, you're going to say to yourself, okay, I multiply straight across. Okay, so when we say we multiply straight across, basically what you're going to do is you're going to make it one big fraction, and you're going to add parentheses around each of those factors. Okay, so this is going to be parentheses, 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 parentheses. Okay. Now, if you just write that, you will get some partial credit, of course, because that is the key step, the idea of you're multiplying straight across. And then once you multiply straight across, you have your one fraction, but now you have to simplify it. So you multiply straight across, and then we simplify, and this is our last step. And the way that you simplify is you factor and cross out factors. Okay, so what you'll do is you'll look at, for example, the x squared minus 16, and that is a difference of two squares. So you'll have the square root of x squared, the square root of 16, gives you x and 4, x and 4. And then one is going to be negative, and the other is going to be positive. Okay, so I'm going to leave a bunch of space here for the factoring work, but what will happen is this x squared minus 16 will become x minus 4 and x plus 4. Okay, and then we'll factor the second fraction. So for the second fraction, we're thinking about factors of negative 12 that add up to negative 1. And those factors will be negative 4 and 3. So we'll have x minus 4 and x plus 3. And that's over 8, which you cannot factor. And then the x squared minus 8x plus 16 will go to factors of 16 that add up to negative 8. So that's going to be a negative 4 and a negative 4. Okay, so you'll have x minus 4 and x minus 4. All right. So if we can either use the chat or the audio, are there any questions up to here about that? Okay, so we have factored, and now what we're going to do is we're going to cross out these factors that are common in the numerator and in the denominator. So this x minus 4 factor is common, and this x minus 4 factor is common. So that's going to leave us with x plus 4, x plus 3, all over 8. And that is our final answer. Okay, so we multiply straight across, and then basically that amounts to adding parentheses around those quantities and then factoring and crossing out the factors.